Okay, so let's look at this session. So for your online final, these questions will be randomly generated from a test bank. So notice this first question asks you for the union. And you might think, well, there's not a single intersection question on this practice exam. The problem is it's going to come from a test bank, and you're either going to have the union question or the intersection question. So you must know how to do both. Okay, so I'm going to do both of these. So this might take a little longer than 2 hours to do the whole thing, because I'm going to go through every possibility you could be asked. So if we want the union, then you just make a single set consisting of both of these. And you can write them down like this, but set notation does not allow for repetitions. So I have a 1 here, nowhere else. A 2 is repeated, so I can't have it in there. A 3 is repeated. And so in proper set notation, without any repetitions, we're going to get that. Okay, and so the answer would be A. If the question had been union, it's just as likely, because it's an online test bank, that you will get the intersection question. So let's see what the answer would have been if it had been intersection. With intersection, the set you form can only be elements that are in both sets. So I just need to go through one set. I look at 1, it is not repeated, so it's not going to be in the intersection. I look at 2, it is contained in both, so it will be contained in the intersection. Then I look at 3, it is contained in both, and so it will be the intersection. And then I'm done. So if the question had been intersection, the answer would have been D. And you absolutely must know how to do both, because you're going to get one or the other. And it just depends on the luck of the test bank, what it gives you. Just get that in focus. Okay, so what we have to be careful on one like this is you're going to have to distribute that negative sign to every term and not just the first term. Okay, so this one has nothing in front of the parentheses, so I can drop the parentheses. Then I have to distribute this to every term. So the negative of negative x is plus x and then minus 5. And then I need to gather my like terms. So I have 4x squared minus 6x squared, which is minus 2x squared. And then I have minus 2x plus x, which is going to be negative 1x, which is just going to be minus x. And then I have 1 minus 5, which is going to be minus 4. Okay, and so you can see the correct selection is C. Now, the most common mistake a student will make, and let me do it in red because red is wrong, is they will not apply the negative sign to every term. They only apply it to the first term. And just do minus 6x squared and then have that. And if that's the case, then they will get minus 2x squared minus 3x, and then plus 6. And you can see it takes you straight to a wrong solution. Okay, and so as far as the random generator is, you're always going to get a negative sign here. And so you must remember to apply it to every term, or else you're going to throw away your points. Okay, let's simplify this. Okay. The common mistake here is a student does not apply the exponent of 4, to everything inside because it is a product. So if I'm going to do this, it gets applied to everything inside. Now, if there was a plus or minus sign symbol there, that's not the rule. Since it's a product, it's going to get applied to everything inside. So this is going to be 3 to the 4th times x squared to the 4th. And 3 to the 4th is 81. And then the rule here is you multiply your exponents. And that's going to be x to the 8th. Okay. And so that's my answer here is A. So what's the common mistake that people make? The common mistake is people do not apply that exponent to everything. And they think, oh, it's going to be 3x squared to the 4th. And then they'll forget the rule that you have to multiply here, something that you have to add. Okay, so if we had gotten the rule wrong here and thought that you would have added, that would have led you to that wrong conclusion. If you don't apply it to every term, that leads you to this wrong one. And then if you add those, which is wrong, it leads you to that one. So these bogus ones are done on purpose to make sure that you know the rules for all of that. All right, which of the following two relations are functions? Okay. Well, if it's a function, you cannot have any repetitions of the first element. And so we can see in here, I've got a repetition of 1 as my first entry. So the first one is not a function. The second one, I don't have any repetitions of first entries. So only 2 is a function. So the answer to that one is C. All right, what is the domain of this function? Well, in a fraction, you are not allowed to have the denominator be equal to 0. So the denominator is not allowed to be 0. So the denominator, which is 2x plus 6, is not allowed to be 0. Okay. And so solve this. Subtract 6 from both sides. That's minus 6. And then divide both sides by 2. So x is not allowed to be negative 3. Okay. X is not allowed to be negative 3. And so we just want to be really careful here. If that had been a not equal sign, then our answer would have been B, but it's not a not equal sign. And so which one of these, it's going to be in interval notation. So if x is not equal to negative 3, then what does that look like on the number line? Well, you include everything except negative 3. So I come here to negative 3 and we got to jump over it. Okay, so the answer is going to be C. All right. Now, what is the domain for number 6? Well, if you have a square root, then everything inside has to be greater than or equal to 0. So, and what's inside is called the argument. So that is going to have to be greater than or equal to 0. So I add 8 to both sides. Doesn't change the arrow. And I divide both sides by 4. Dividing by a positive side does not change the arrow. And so that's my answer, but you can see all the answers here. The selections are in interval form. So what does it look like on the number line? Well, I start at and I include 2, and then the arrow's pointing to the right, everything bigger than 2. So I include 2 and everything bigger than 2. And so we're going to get that. Okay. And so my answer is going to be A. Okay. All right, let's look at number 7. It wants to know what is f evaluated at x plus 5. Okay, so what I'm going to do is I'm going to rewrite the formula for f, and everywhere there's an x, I'm going to replace it with blank parentheses. So I have f of equals something squared minus 4 times something plus 1. Okay. Now, we've been asked for f evaluated at x plus 5. So everywhere in here, I'm going to put x plus 5 inside the parentheses. And strictly speaking, this is a correct answer, but you can see none of these selections look like that, so I have to expand it. X plus 5 all squared is not x squared plus 5 squared. It's x plus 5 times x plus 5. Then I must distribute negative 4 to every term. So I'm going to have minus 4x minus 20. All right, then I'm going to have to FOIL this. That's going to be x squared plus 5x again, plus 25, minus 4x, and then that will give me minus 19. Okay. And so I'm going to have x squared. 10x minus 4x is 6x. And 25 minus 19 is going to be 6. Okay, so that's what I'm looking for. X squared plus 6x plus 6. Okay, and that's matching up with C. Okay, now number 8, it's a randomly generated question, and so you could be asked, well, first of all, let's see what we have. The easiest way to do this, quickest way, is to put that in your graphing calculator and look at it. So if a function is odd, then if you turn it upside down, you get exactly the same function. And if you have a piece of paper, you can do this. I'm going to take it and I'm going to turn it upside down and I get exactly the same graph. So that is an odd function. Now, if a function is even, then it is symmetric with respect to the y-axis. And symmetric to respect to the y-axis means if the y-axis is a mirror, then you would expect to get its reflection on the other side. And it doesn't matter which side you start with. Okay, so let's put, and we might have to change the window to make it clear. So we'll start with a standard window. All right, press Y equals, clear out any old data, and I'm going to put 2x cubed plus x. And then I'm going to start with zoom 6. Okay, I think you can see it as it is. It's going to be odd because if I take my graphing calculator and I turn it upside down, I get exactly the same picture. But you know, we've got all this wasted space in here. I could just change my, all right, and that is, if I turn this upside down, I get exactly the same picture. And that's what you have if you have an odd function. Okay. Now, the one that they'll give you comes from a test bank. And so for this one, we had an odd function. You might have a function that's even. You might have a function that's neither one. Okay. Just be careful. They can have the same shape, but they're not exactly the same. So look at this one. What about that one? Let's have a look at that. So I'm going to press that. Press Y equals. Let's clear that out. Let's do x cubed plus 3. And let's start with a zoom 6. Now, you got to be very careful here because if you turn it upside down, it does have the same shape, but it is not the same graph. Notice that this crosses the y-axis above, 3 units above the x-axis. But when I turn it down, this is not the exact same graph because it intersects the y-axis when it's below the x-axis. So this one is neither. So you have to be really careful. It had the same shape, but it wasn't exactly the same function, same graph. Okay. All right, how does the graph of f of x plus 3 relate to the graph of f of x? Well, we have to remember our transitions. So there was a chart, And if the x is replaced with x plus k, then what happens is we have a left shift of k units. So k is a positive number. And if the x inside the parentheses is replaced with f of x minus k, then that's a right shift of k units. Okay, so what we're going to have is we're going to shift left 3 units. And so I'm looking for left of 3 units. Okay. So you don't want to get these mixed up with horizontal and vertical shifts. Now I can tell you that the one this year has both of them together. And there's a graph, and so maybe the one in 2017 is more. So I would expect to see on your number 9, you know, what's that going to do to the original graph? Okay, well, this one is a left shift of 3 units. And then when it's outside, we're going to shift that one down 3. And so you need to know the difference between vertical and horizontal shifts. All right, if you've got something like this, well, this is outside of F, and so that's going to be shifting it up 3. But because X is replaced with X minus 3, that's a horizontal shift, and that's 3 units right. So the one on your final this year, you're going to have to know how to do 2 shifts like this. Okay, so it is more difficult than just number 9. Okay, now number 10, how does the graph of that relate to the graph of f of x? Okay, so we have to remember what the rules are. And so here's what we do. You might think, well, I don't have a picture. Okay. Well, you can make your own picture. Okay, because here's what I'm going to do. From the rules, if f of x is changed by multiplying something out the front, then your old point, x comma y, will be changed into a new point, and it will be found if the number is multiplied out the front by multiplying the y coordinate by k. All right? So that's one rule. Now the second rule is if you change the formula of f by multiplying k inside the parenthesis there, the way that changes is it takes a point on the original graph, and your new point is going to be, it'll change the x coordinate, but you don't multiply k times the x coordinate. You multiply the old x coordinate by 1 over k. Okay. So let's just draw a really simple graph. Okay, because they don't give us a graph, so we can draw a simple one. And okay, so I'm going to have something very simple. 2 comma 2, and then 4 comma 4. Okay, that's a very simple graph. Okay, so now I want to get the graph of negative f evaluated at 2x. So what are the points on that graph going to be? Well, how do I form it? Well, I can use these rules. Okay. So one way I can do this is I can start with f of x, and I can go to multiplying the outside by -1, which is the same thing as minus f of x. Okay, and so if I start with a point on f, it will be changed into, well, the y coordinate will be multiplied by -1. Okay, and then I take this one and I change it. Well, I want to make it look like that by multiplying inside here by 2. So what's it going to do to this point? Well, it's going to change this point's x coordinate, and the new x coordinate is going to be 1/2 times whatever this one is. And it doesn't change this y coordinate. Okay, so if my point on f is 2, 2, then the point on this one is going to be 1/2 times 2, which is 1, and the negative of the y coordinate. So I'm going to have 1 times -2, 1 comma -2. So 1 comma -2 is there. And then what happens to 4 comma 4? Well, the x coordinate will be divided by 2, or multiplied by 1/2. So 4 divided by 2 is 2. And then my y coordinate will be negated. And so I'm going to have -4. So this will go to 2 comma -4. And 2 comma -4. So now let's see what's happened to this one. It started out above the x-axis, and it's ended up in below the x-axis, and one of the steps was we did a reflection on the x-axis. If we'd done a reflection in the y-axis, it would have ended up over here. So let's look at these. We're only going to be reflecting it over the x-axis. So you can immediately rule out A and C. Now there was a typo here. This was meant to be selection D. Now what else is there to be? So we can rule out A and C. Now what else is left if we rule those out? We have to decide between vertically stretching or horizontally compressing. Well, what's the height of this? So this goes from 2 up to 4. So this has a height, a vertical height of 2. What's the height of this one? Well, it goes from -4 up to -2. And so its vertical measurement is also 2. So nothing was done to the vertical. It was the horizontal that was done, changed. So we can see here what's the horizontal measurement of this one. Its horizontal measurement is 2. What's the horizontal measurement of this one? Its horizontal measurement is 1. So we flipped this over the x-axis, and then we did a horizontal compression. So the answer would have been D. Okay. Now, on yours, they give you a graph. And only one of these is going to happen. Notice you had 2 here. You will have a graph, And you'll be asked, so you'll be given a graph of f, and you'll be asked which one is either that one or that one. Okay. Again, it's randomly generated. So on your final, you'll have to know horizontal and vertical together in one question. And for this one, you only need to know one of these. Now, which one are you going to get? It's randomly generated. Okay, so if you have something like this, and this is not what you have, okay, so if you have something like, okay, so that's all 1, -1. Okay, so what would this one look like? Well, points on the original will go to, if it's outside, your new y coordinate is -1 times that. And so with the multiple choice selections, you can see that this point is 1, 1. You'll find the one that has 1, -1 on the graph. Now, if you're asked for that one, how is that going to change the point on the original? Well, the x-axis will be changed, and it will be 1 over -1 times x, which is just -x. And so if 1, 1 is on this one, you're going to look for the graph that has -1, 1 in the graph. All right, so I'm going to stop that there because that's the first 10.